All right, to do example 4, we're basically just going to follow the definition of the derivative and then plug in the numbers and then evaluate the limit. That's basically all that happens. So here we want the point x equals 5, so we're going to calculate f prime of 5. According to the definition, 5 is our p-value, right? So that's 5. So everywhere that we see a p, we're going to put a 5. And then the h's and the limits, that's all the exact same. Limit as h approaches 0 of f of 5 plus h minus f of 5 divided by h. So what is f of 5 plus h? Well, f of x is x squared. So f of 5 plus h just means I'm plugging in 5 plus h. For x, it's 5 plus h squared. So this is 5 plus h squared. Now f of 5 is just plugging in 5 for x. That's 5 squared divided by h. And now we just keep simplifying. 5 plus h squared, well, 5 plus h squared, that means 5 plus h times 5 plus h. And when I FOIL that out, I get 25 plus 5h plus another 5h, so that's 10h plus h squared. Notice that if you do this calculation as 25 plus h squared, you actually kill a puppy, so don't do that. So 5 plus h squared, that's 25 plus 10h plus 25, just kidding, plus h squared. 5 squared is 25. That's all divided by h. Our 25s cancel, and we get the limit as h goes to 0. 10h plus h squared, well, I can factor an h out of that to just give me just h times 10 plus h. And once I factor that out, I can cancel the h's. And what is the limit as h goes to 0 of 10 plus h? Well, that just means I'm plugging in 0 for h. And I just get 10 as my answer. Then example 5 says find the equation of the tangent line to the curve f of x equals x squared at the point where x equals 5. Now, if we want the equation of a line, there's two different equations of lines that I know. There's y equals mx plus b, that's the slope-intercept form. And then there's also y minus y1 equals m times x minus x1. This is the, point slope formula. So it's a point x1, y1, and the slope m. So this was the x squared at the point x equals 5. That was what we just found. So f prime of 5, that's equal to 10. That's equal to m. It's equal to the slope of the line for the tangent line. So what we just calculated in the previous example is this m value. And all we need is, I'm going to use the point slope formula here. All we need is our x1, y1. Well, our x1 is equal to 5. That's our x value. And what is our y1? Well, y1 is what we get when we plug 5 into the function. So 5 squared is 25. So our line is given by y minus 25 equal to 10 times x minus 5. And if I multiply this out and add 25 to the other side, this becomes 10x minus 50 plus 25, simplifies down to y equals 10x minus 25. Some people also do it this way. If you use the slope-intercept form, you have y equals mx plus b. We know that m is equal to 10. All we need to know is the intercept, and to find that, you can plug in your y value of 25, m is 10, and your x value of 5. When you subtract that, 10 times 5 is 50, subtract that to the other side, you get negative 25 equals b. So your final answer is y equals 10x minus 25, which is exactly what we got before. So either way you want to do it is fine. you do need to have at least one of these forms memorized and be able to calculate lines in that way. So we're going to do an exercise now, and basically the idea for this is when we calculated the tangent line here, the derivative, we found it at a specific point 5. But you could actually do it more generally. Instead of a number 5, you could put in a letter, p, really just like what we have here, and do the exact same calculation with the variable p instead of the number. And this has some nice benefits to it, as I'll explain after we do this problem. So you're going to try to do exercise 6 on your own. The work is going to be almost identical to what you did in example 4. The only difference is that instead of a 5, you're going to be just putting in the letter P and then doing the same types of calculations. So pause the video now, try it on your own, and then I will go ahead and work it out after that. Okay, so what we're looking for is f prime of p, which by definition is the limit as h goes to 0 of f of p plus h minus f of p divided by h. And our f is x squared. So if I plug in p plus h in for x squared, I get p plus h quantity squared. And f of p, that means I'm putting in p for x, that's just going to be x squared. And that's divided by h. And when I multiply this out, remember I've got to do p plus h times p plus h and FOIL it. I get p squared plus 2ph plus h squared. Oh, just kidding, that's not x squared right there. That should be p squared. Right, because I'm putting in p in place of x. So minus p squared divided by h. My p squareds cancel. Notice, if you want to just look back at the example before, this is exactly where we were before, but the 25s were canceling because p is equal to 5, so p squared would be 25. So we're doing the same thing we did before. And now I've got 2ph plus h squared. I can factor in h out of that to get h times 2p plus h over h. H's cancel, and if I plug in h equals 0 for h, I just get 2p. And notice our previous answer, we got our slope was 10 because p was 5. 5 times 2 gives us 10. What I did now is I just found this general expression, and now I could find the slope at any point, not just 5. So this is a much better result in general.